All right, let's talk about atomic number and isotopes. So the atomic number and the mass number indicate slightly different things. So the atomic number is designated Z. That's the number of protons. Incidentally, it's also the number of electrons, just because in a neutral atom, you have the same number of protons and electrons. And then the mass number, it tells you the number of protons plus the number of neutrons. The reason it's not just the number of neutrons is because that's actually variable. So we would write it out like this. X, A, Z, where Z is the mass number, or is the atomic number, and it's the number of protons. A is the mass number, and it's the number of protons plus the number of neutrons. And then X is the element symbol. So for nitrogen, the atomic number is 7. And if it had 8 neutrons, then the mass number would be 15. So anytime, the reason that the mass number is important is because you can actually have different numbers of neutrons. Now, you can find the number of neutrons if you have the atomic number, the mass number. So if I told you, oh, how many neutrons are in 15N? Well, it's 15 minus 7 or 8. And if I said, well, this nitrogen has 8 neutrons, what's the mass number? You say, well, it's 8 plus the atomic number 7, which is 15. So you can find the number of neutrons given the mass number and the mass number given the number of neutrons, because the atomic number is tied to the symbol. So isotopes are when you have the same element with different numbers of electrons. So if I have a hydrogen atom, then it typically, one hydrogen atom will have 1 proton and 1 electron. Okay, and that's regular hydrogen. Well, deuterium, hydrogen 2, has 1 proton, 1 neutron, and 1 electron. And then tritium, hydrogen 3, has 1 proton, 2 neutrons, and 1 electron. You might notice that these are going to weigh different amounts. So that's going to have a weight of 1, that's going to have a weight of 2, that's going to have a weight of 3. We're going to come back to that later. And you might have heard of carbon-14 dating. That's because carbon-14 is an isotope. But there are a lot of isotopes, and some of them are radioactive. So basically, if an isotope is stable, then it's not going to be radioactive. It's going to be mildly radioactive. But if an isotope is unstable, then it will very rapidly break down into functionally different elements and release a lot of energy. That's radiation. But isotopes kind of exist in nature, and they're the reason, which we'll look at in another video, they are the reason that you don't have nice round numbers. So we're like, oh, if a proton weighs 1 and a neutron weighs 1, what are all these decimals doing in my periodic table? And the answer is because of isotopes. So it's also the reason that bananas are radioactive. So the atomic number, again, is in the periodic table. Mass number, isotopes, it has to do with the number of neutrons.